In this lab, I was tasked with performing dynamic malware analysis and behavioral profiling of a suspicious executable. The goal was simple: run the malware in a safe environment and study its behavior, everything from file changes to registry edits and possible communication with command and control servers. Before we go further, please remember, this walkthrough is for educational purposes only. All steps are demonstrated in a controlled, ethical lab environment to support learning, awareness, and proactive defense development. I started by preparing my virtual lab using Flare VM, which was configured in host-only network mode to ensure no real internet communication could occur. This isolated environment was crucial to ensure that even if the malware attempted to connect to an external server, it wouldn't leave the sandbox. Next, I extracted the sample provided from the GitHub link, navigating deep into the file path until I found the executable named budget-report.exe. Right away, the name looked suspicious, something crafted to appear harmless, but clearly part of the lab's intent to test how malware hides in plain sight. Before executing the sample, I launched all my monitoring tools: Procmon, FakeNet-NG, Regshot, and Wireshark. With Procmon, I paused the capture and cleared previous logs to make sure I'd be working with a clean slate. I also launched FakeNet-NG to simulate network services and capture any attempts by the malware to reach out to external domains. Then I opened Regshot and took the first snapshot of the system registry, my baseline before infection. With all tools in place, it was time to run the malware. I resumed the Procmon capture and executed budget-report.exe. I let it run for about 3 minutes, observing any immediate behavior. During this time, the system didn't show any unusual errors or pop-ups, which is often the case with stealthier malware. These types of executables prefer to operate quietly in the background, avoiding detection. After the time had passed, I paused Procmon and returned to Regshot to take the second snapshot. Then, I compared the before and after to identify any changes made to the registry. This revealed key behavioral indicators that would help define what this malware was trying to achieve. Then I turned to Wireshark and FakeNet-NG logs to analyze the network behavior. I was particularly interested in DNS queries, HTTP requests, or any traffic that indicated communication attempts to external IP addresses or domains. While FakeNet prevented these requests from reaching the outside world, it still logged them, allowing me to trace their behavior safely. In Procmon, I filtered the logs to focus on file writes, registry modifications, process creations, and network activity. What stood out to me was a recurring process that attempted to modify files inside the updated directory, a common tactic used by malware to hide from plain sight and avoid privilege escalation warnings. One interesting find came from checking the task manager. Under the Startup tab, I noticed a file named bindif_config_setup.exe marked as enabled with medium impact. This was not a process I had seen in the system before running the malware. The fact that it appeared post-execution and was enabled at startup suggested that the malware was attempting to maintain persistence on the system, ensuring it could reboot and continue its operation even after the host restarts. Digging into the registry, I found keys that pointed to this file being added to the system startup routine. This confirmed that persistence was one of the behaviors coded into the sample. Combine this with the network request code by FakeNet and the file system changes from Procmon, and I had a clear profile forming. The malware was silently embedding itself into the startup routine, creating or modifying files in low-visibility directories, and attempting to communicate outbound, likely to receive further instructions or upload stolen data. This lab reinforced the importance of layering your analysis tools. Each one provided a piece of the puzzle. Regshot highlighted registry tampering. Procmon tracked file level and process activity. FakeNet and Wireshark gave visibility into network communication attempts. Task Manager provided evidence of persistence. From this lab, I learned how to approach malware analysis not just as a technical task, but as an investigative one. It's not enough to see that something runs, you have to ask, what did it change? Where did it try to go? And how does it plan to survive? The indicators of compromise I documented, from startup entries to outbound network attempts, would be valuable for any SOC or blue team. These IOCs could feed into alert rules, endpoint detection systems, and firewall configurations to stop future attacks using similar techniques. Overall, this dynamic analysis gave me first-hand insight into how malware behaves once it breaches a system. More importantly, it gave me a process to detect, document, and defend against those behaviors. That's what dynamic malware analysis is all about, watching the enemy in motion, and turning every move they make into a lesson that helps us protect what matters most. Thank you for following the entire dynamic malware analysis and behavioral profiling lab. The full documentation, command list, and scripts are available via the links in the description. And if you're passionate about red teaming, threat emulation, or ethical hacking, connect with me on LinkedIn or explore my GitHub for more security-focused content. Until next time, be vigilant, be ethical, and keep strengthening your defenses.